All right, welcome back, everybody. Today we're going to be going through and doing the homework help video for section 3.4a. This is a worksheet. So looking at problem number 2 here, when we get to a problem like this and we want to solve it, one thing we like to do, if possible, is rewrite the bases in terms of one another. If we can do that, that normally makes a much easier problem to solve. If we can't do that, then what we're going to do is take the natural log of both sides, right? Whatever we do to one side, we can do to the other and still keep it balanced. Now, remember, if you try to take the natural log of something that has an exponent, you can pull that exponent down in front. So 2x, natural log of 5, is equal to the natural log of 20. Now, of course, this is hooked on by multiplication, so we can divide it off. ln of 5 divided by the ln of 5. These two pieces will cancel each other off, and I'll just be left with a 2x over here. Now, obviously, to get 2x alone, I would divide by 2, so I'm going to take whatever this answer is here and end up dividing it by 2. And when I do, I'm going to find out what x is. Now, I don't know that I'm going to punch in every last one of these, but I will do this one. So, not second, I just want the natural log of 20 divided by the natural log of 5. I'm just going to get that number, and then whatever that number is, I'm going to take it and divide it by 2. So I end up getting that x is equal to 0.9307. So this is what my x value is. Now, one of the nice things about this problem is how easy it is to plug back in and to solve and to check. So if I just take 5 and I raise it to the 2 times my answer's power, so I can just go grab that, you can see that I come out with 20, which means I did my work correctly. Now, I don't know that I'm going to plug in every single one on my calculator. I'll probably pick and choose, but that would be one way to do it. Now, looking at this problem over here, a different way you could consider solving this is that if you realize that 25 is just 5 to the second, then you could come over here and rewrite this as 5 to the second and then times 2n plus 1. The exponent's still there. I'm just rewriting 25. And then 625 is actually 5 to the 4th. Now, the nice part about rewriting something in this manner is that you know that this needs to equal this. So I can come over here and just set this up as a new equation, and I can solve. Distribute this through. 4n plus 2 is equal to 4. 4n is equal to, subtracting 2 from both sides, I get 2. Dividing that out, I get n equals 1/2. Now, that's kind of neat, and that's great. Let's show you another approach you could have taken. So if you didn't realize that these two things could be written as the same base, how we wrote them both as a base of 5, then what you could do instead is you could have went at it with that natural log trick we used before. So taking the natural log of both sides, our exponent is going to come to the front, not equals, times our natural log of 25 is equal to our natural log of 625. Dividing both sides by that extra natural log. These two cancel off. So I'm going to be at 2n plus 1 is equal to the natural log of 625 over the natural log of 25. Now, of course, we haven't gotten n alone yet, so we're going to need to subtract 1 from both, and then to get rid of the 2, we would end up dividing everything by 2 eventually, right? So it's important we do those in the right order, but I do want to show you that this will give us the same answer. So coming over here to our calculator, I'm not going to try to type that all in at once. I'm just going to do it in parts. So ln of 625 divided by the ln of 25. Whatever that number is, take away 1 and divide that by 2, and we get n equals 0.5, which is, of course, 1/2, which is the same answer we got on the other part of the problem, right? So multiple ways to do the problem. It's great. Looking at problem number 6, whenever you have that extra piece, you need to first start by moving that to the other side. These two cancel off. I get 17 is equal to 4x. Taking the natural log of both sides, the exponent's going to come down. I'll have the natural log of 4 is equal to the natural log of 17. Dividing by the natural log of 4 on both sides to keep it balanced. These two cancel out, and this is what x will be equal to. Obviously, that you'll punch into your calculator and still get a decimal. Looking at problem number 8, I think I could write these in the same base, but that's going to be a lot of work, so I'm just going to go with my ln approach. So I'm going to take the natural log of 64. The x is going to come down to the front. That's hooked on by multiplication, is equal to the natural log of 4096, dividing by the natural log of 64, and the natural log of 64. These two cancel out, and I'm left with x equals that. Of course, that's a decimal. You'll punch that in on your calculator. Looking ahead to problem number 10, base of 3, base of 2, I'm just going to take the natural log of both sides. Now, this is the exponent, so that's what's going to come down in front. X over 7 is equal to the natural log of 2, dividing by the natural log of 3 on both sides. These two will cancel off. I'll be at x over 7 is equal to the natural log of 2 divided by the natural log of 3. Now, x is not alone. To unhook that 7, we're going to multiply both sides by 7. So I'm going to get x equals whatever this is as a decimal times 7. That is what your answer will be. Looking ahead to problem number 12, again, I think I could rewrite these using similar bases, or I could just do the natural log approach. This one, I think I'm going to do it with similar bases. So 36 is really just 6 squared. So I can rewrite that, and then I'm still going to have that exponent of a negative 2x plus 1. 216 is really 6 to the third power, I believe. Let me double check that. It's where it's really good to know your power. 6 to the third, 216. So when I come over there, since they both have the same base, I know their exponents must actually be equal to one another in order for them to be equal. So I'll get 2 times negative 2x plus 1 is equal to 3. Distribute, distribute. I'll get a negative 4x plus 2 is equal to 3. Negative 4x. Subtracting 2 from both sides is equal to 1. And then dividing by negative 4, I'll get a negative 1/4 is what x is equal to. And again, it's easy to go back and plug that in if you wish. Looking ahead to problem number 14, I'm going to take the natural log of both sides, so my 2n minus 1 is going to come down in front. Natural log of 12, obviously hooked on there by multiplication, is equal to the natural log of 64, dividing by the natural log of 12. These two cancel out. This will just be a decimal over here. So I'm going to get 2n minus 1 is equal to the natural log of 64 over the natural log of 12. Now, I'm not doing this where I'm punching it all out and getting a decimal and doing it kind of step by step. I'm combining steps right now. Remember, you would add 1, so adding 1 to both sides, and then I would take or divide by 2 to get x alone there, or n in this situation. So I'm going to have to do it in that order and be careful about it, but n will end up being equal to that decimal. Looking ahead at 16, this one's unique because it has a base of e. So again, start it out the same way. Take the natural log of both sides. So doing so, 793. When I do this, the natural log of e is just equal to 1. So this basically cancels itself out. So I'm left with 1 minus 5x is equal to the natural log of 793. Subtracting 1 from both sides, I get a negative 5x is equal to the natural log of 792. Oh, actually, I'm sorry. This is a quantity, right? So it's the natural log of 793 minus 1, right? This is a decimal. You got to figure out that decimal first. Then last but not least, dividing by negative 5. So taking all of that, dividing by negative 5, x will be equal to that as a decimal. Looking at problem number 18. Again, let's move the 2x down in front. So 2x, I'm going to take the natural log of both sides. So natural log of 10, natural log of 9, dividing by the natural log of 10 on both sides. These two cancel off. I'm going to have 2x is equal to that. Obviously, I'm still going to need to divide by 2. So dividing by 2, taking that whole answer, dividing by 2, I'm going to find out x equals. Now again, just as a reminder as to how you do this on your calculator, this happens first. So do the ln of 9 divided by the ln of 10. Once you get that number, then take that divided by 2. Don't try to combine that into more than one step. So 0.4771 will be our answer for that problem. And again, you can always check it. So just taking 10 raising it to the 2 times 0.4771, we end up with getting basically 9, right? But we chopped off our decimal, so that's why we're not seeing it exact. It looks like 2 more problems here, so here we go. Looking at the natural log of 10, I'm going to bring my x minus 2 down in front, is equal to the natural log of 0.3, dividing by the natural log of 10 on both sides. These two cancel off. And then, of course, to get x alone, I would have to add 2 to both sides. So x would equal the natural log of 0.3 over the natural log of 10, and then plus 2 to give me my final answer. Last problem we're looking at today, number 22. I believe I better zoom out and just make sure here. Yep, so looking at problem number 22. Again, you're going to have to start by getting rid of any extra pieces, so that 2 is going to have to go away. I'll be left with e to the 3x plus 7 is equal to 241. Now, to solve this, I want to take the natural log of both sides. So the natural log of e, of course, my exponent drops down in front, is equal to the natural log of 241, dividing by the natural log of e. Well, actually, hold on. Natural log of e is just 1. So this basically all goes away. So I'm just left with 3x plus 7 is equal to the natural log of 241. Trying to get x alone, we want to subtract 7 from both sides. That would take care of that piece, and then divide by 3. So taking all of this divided by 3 will tell me what x is. Just like that, ladies and gentlemen, that's how we go through and solve exponential expressions. If you have any questions, please don't hesitate to reach out and let me know. Thanks. Have a good day.